In our shop today, we have a 2002 Chevrolet Trailblazer with a 4.2-liter engine and over 217,000 miles on it. The owner is complaining of loss of power, poor fuel economy, misfires, and the check engine light is lit. When the vehicle was brought to the Wells garage, it was obvious the vehicle has a misfire. We first connect the scan tool and read the codes. There were two codes stored, a P0306 and a P0014. P0306 means a misfire has been detected on cylinder 6. We then look at the misfire counter. Notice that cylinder number 6 does indeed have the majority of the misfires. But we also notice there are history misfires saved on all other cylinders as well. Remember, we also have a code P0014, which indicates the cam facing or variable valve timing difference between the desired and actual angle is more than 1.5 degrees, or the cam facer is steady or stuck in place for more than 20 seconds. The PCM must see one of these issues for more than 2 consecutive key cycles for the code to set. On our scan tool, we activated the variable cam timing or VCT solenoid. To activate this test, the RPM must be between 1,000 and 1,500. When the test was activated, we continued to increase the on-time percentage, which should retard timing and change RPM. As you can see, no matter where the VCT solenoid was commanded, the RPMs did not change. This could be, several things could be happening here. For example, if the oil is old or contaminated, which is very common by the way, the variable cam timing will not function properly. But we did check the oil and it was changed a little less than 2,000 miles ago. We also pulled the dipstick and it looked good, but it had a slight scent of fuel. This could be because of the misfire problem. The next most likely cause for no change in RPM is an issue with the VCT solenoid. It might not be activating or the screens might be restricted. We decided to pull it out and have a look. To remove the VCT solenoid on this vehicle, it is necessary to move back the power steering pump a little. To do this, remove the serpentine belt and loosen the 3 bolts on front of the pump. With a little push backwards on the pump, the solenoid will pull out. With the solenoid on the bench, you can see there is a lot of debris in the screens, which will restrict the oil flow. We cleaned the screens and removed most of the debris. We also activated it. This can be done with a 12-volt battery and a couple of jumper wires. This test can also be performed on the vehicle while the engine is running. If the solenoid is activated on the vehicle, the RPMs should drop. On the bench, you should see the internal pintle move. While we were activating the solenoid, we noticed another telltale sign that it was effective. Look inside the connector. There is a sign of engine oil. This occurs because the internal seal has failed and allowed oil to leak into the connector. Whenever you see this oil inside of a connector, the solenoid needs to be replaced. We next installed the new VCT solenoid, tightened the power steering pump, and reinstalled the belt. Now, when the VCT solenoid is activated, the RPM injector pulse width is reacting, telling us the variable valve timing is functioning. Could the VCT solenoid have been the cause of the misfire we were experiencing? Maybe, but let's take a closer look. Now, when we view the misfire counter, only cylinder number 6 experiencing misfires. We are now going to use a lap scope to determine what is going on with that cylinder. Our lap scope check will start with a look at the wiring diagram and the underhood fuse box. Behind me, there is the beginning of a wiring diagram which starts with the underhood fuses. We are going to point our focus to fuse number 28. This 15 amp fuse connects battery voltage to the 439 pink wire. The pink wire will split off and connect power to the PCM, ignition coils, and fuel injectors. By removing fuse 28 and plugging in a fuse buddy in its place, we are able to view the entire amperage draw on the pink wire with our lap scope. Okay, take a look at this pattern. Okay, stop the pattern here. The oscillations along the bottom represents either a little noise in the circuit or the amperage being drawn by the PCM to make calculations. Notice right here the small rise in current flow. This is the amperage the injectors are drawing. Look at the high spikes. This is the amperage the ignition coils are using. This is a 6-cylinder engine, so if all coils are firing, we should have 6 coil spikes. Let's start counting here. 1, 2, 3, 4, 5, and this spike is missing. Do you think this might be related to the misfire on cylinder number 6? We changed the coil number 6, and this is our new pattern. As you can see, all the coils are firing and the misfire is gone. We cleared the codes and went for a road test, and the vehicle ran great. That's it for today. If you'd like to see more testing using a scope, just let us know. We'll see you again soon in the Wells Garage.